we are going to solve for plus C, meaning that we're going to solve for the initial value problem. Okay, so all of this is free response. Solving the initial value problem is 7 out of 9 points on a free response test. So each question on a free response is worth 9 points. 7 out of 9 for one particular question is this process. Typically, what goes with this process is your end question for today, which will be 1A, which is the slope field. I want to remind you guys of slope fields. So 1A is your end question, which means that more than likely your beginning question tomorrow is going to be a separation of variables, right? Which is what we're doing right now. I will tell you that this is showing up on the AP test every single year on every single form since 1997. It is 100% showing up on your AP test. It is showing up on the non-calculator portion, more than likely, of your AP test. So much so that I will tell you that if you turn in your AP test without doing this process, you've lost 7 points. So you have to find somewhere on your non-calculator free response to do this, because more than likely it's on non-calculator. I think only 1 or 2 years have I seen it show up on the calculator portion. Okay, so College Board is very particular. I'll choose my words carefully. Very particular about how they want things. So I understand that multiplication and addition, like there's a commutative property, right? And so it doesn't matter which way you go, if you put y's on the right or y's on the left. College Board is very particular, so if you do not do it their way, you do not get credit. They expect all of the y's on the left-hand side and all the x's on the right. So they also are super picky, so it's going to totally mess up all my step skippers if they do not see step 1, which is separation of variables. You get 0 out of 7 points. And it is the dumbest step in the world. The step is move all the y's to the left, including dy. Move all the x's to the right, including dx. That's it. So I leave dy on the left, and I move, in this case, just the dx to the right. Because what I'm going to try to do is take an antiderivative. So the way that you can do this is make yourself feel a little bit better about life. Put the integral symbol there because you're going to take the antiderivative when you separate the variables. Step 2 is to take the antiderivative of both sides. So the antiderivative of dy is just y. Antiderivative of 9x squared is 3x cubed. Antiderivative of negative 4x is negative 2x squared. And then this is a plus 5x. And then a plus c. Okay, so how do I solve for plus c? I have an initial condition, an x value and a y value that I can use. So I plug in my initial condition. So I have 0 is equal to 3 times negative 1 cubed minus 2 times negative 1 squared plus 5 times negative 1 plus c. If they do not see you plug in your initial condition, you only at most get 3 points out of 7. if they do not see this step. So if you randomly come up with a random letter, C is equal to something, it does not work. I don't care if you can do it in your head. If they expect to see, you plug in the initial condition, which again is terrible for all of my step skippers. So I get 0 is equal to -3 minus 2 minus 5 plus C. So C is 10. Step 3 is done. Step 4 is to plug in C. So y is equal to 3x cubed minus 2x squared plus 5x plus 10. If it didn't work out nicely, my fifth step would have been to isolate y. What it means to isolate y is y has a coefficient of 1 and exponent of 1. And unless those two conditions are met, you have not isolated y. In this case, in step 4, we have already isolated y, so we're done. It's a nice, easy problem. Yes, Jack?
For a college board, it's been when we do like u sub and then we have to change the bounds for u. When we change it back to x, do we have to like change the bounds just for that one u step and then change it back? Or
Once you change the bounds for u, you don't resubstitute u back in.
like with the x?
So you change the bounds so that everything is in terms of u, and then you never change anything back to x.
Oh, okay. I was doing problems with Shannon. He was like, you can just keep the bounds then put it back into x. So I shouldn't do that.
No. You will get points docked off, or you'll get the wrong answer. All right. Any other questions that you guys have? We're going to do a slightly harder one. Now, the issue with this is that you don't ever read until it's too late. So you typically don't read directions because you're like, oh, I know this entire section, I'm supposed to separate the variables. And then because you don't read, you don't know when you're supposed to separate the variables and when you're not. Like when it's asking you for something different. So we're going to take a moment to read. It says, consider the differential equation. So I have a derivative. I want to find the particular solution to the differential equation. What that means is I want to separate the variables. That's your key words for, hey, I got to separate the variables. Finding the particular solution. Bless you. There is a typo. It should be a positive 1 for my y value for my initial condition, not a negative 1. Okay. So now when I do this, I have my dy dx is equal to 1 plus y over x. I have to separate the variables. When you separate the variables, don't break math. Don't forget opposite operations, right? I have my 1 plus y in the top. To get it over to the other side, I have to divide, right? If it was in the denominator, I would have had to multiply. Don't do weird stuff with opposite operations, okay? Be surprised what I see. And when I move the y terms to the left, I have to move everybody to the left that's holding hands with that y. So I have to move the entire 1 plus y to the left. Okay. So I have 1 over 1 plus y dy is equal to 1 over x dx. What you notice is that the question also says to state the domain. That's because we got to deal with land. Everybody's favorite. Okay. So here's my step 1 of separation of variables. Now, it looks like land on the left-hand side. right? Technically it is. U would be equal to 1 plus y. Du is equal to dy. So this is 1 over u du is equal to 1 over x dx. And when I take my antiderivative of 1 over u and 1 over x, I get ln's. So I get ln absolute value of u is equal to ln absolute value of x plus c. We only write 1 plus c, and it's always on the right-hand side. We don't ever do it on the left. Because a plus c on the left and a plus c on the right technically is still plus c. It just represents whatever the initial condition is. So we don't write it on both sides. I resubstitute my u back in. And then I solve for c first. I will tell you guys, if you look at the College Board rubrics for questions, right? So if you were to search and try to find the answers to some of these questions, they do it different on College Board, which is stupid the way they do it. If you do it the way that I do it, you will maximize the number of points you can possibly get if you decide that 2 plus 2 equals 7 for some reason, right? If you mess up your arithmetic, I can still guarantee you're going to get most of the points possible, and you're only going to lose probably 1 point, right? But if you do it College Board's way, you'll lose 3. Okay, because they do it backwards. Okay. So I'm going to solve for c. I got to plug in 1 in for my y. And I got to plug in -1 in for my x. Okay. So I get the ln of 2. And the ln of -1 in absolute value is the ln of 1. The ln of 1 is 0. So I get my c is equal to the ln of 2. Then I have to plug it back in. Ln absolute value 1 plus y is equal to ln absolute value of x plus c. Sorry, plus ln of 2. Just kidding. Yes, Nahal. No, I told you there's a typo.
Oh. So why is the x in there?
Huh?
Why is the x in there?
Because the x is still -1 here.
Oh,
The typo is only with the y value. And the only reason why there's a typo with the y is because otherwise you would get the ln of 0, which is undefined. That's how I knew that there's a typo. Because I couldn't have gone the other way. This is a College Board release question, too. I think it's 2004 is this free response question. Okay, where you are at right now, you have earned 6 out of the 7 points possible. My daughter wants the 6-7 wrappy paper for Christmas. Yeah, there's 6-7 wrappy paper. And the 6 is in a hand and the 7 is in a hand and they're like this. It's on Amazon too. Okay, you only get 1 more point for isolating y. Okay, so I don't know why nobody in 0, I said the exact same thing in 0 period and nobody laughed. There was no reaction. All right. Okay, so you have gotten all but 1 point here. The way you get 1 more point is by isolating y. So I have to finish this first.
You're okay. I just need a calculator checkout. Can I give you the form?
Have her come in like 5 minutes.
5. Okay.
Okay, so all you need is 1 more point to isolate y. Here's the problem with this, okay? The problem with this is that it's going to take you a lot of effort to isolate y. because we have to deal with y and also the fact that we have absolute value. So I'm going to tell you, while I'm fully confident in your ability to isolate y, I am. I know you guys look at me like I'm lying to you, but no, like I'm fully confident in your ability. The problem is that there's other problems to do, right? Typically on a test. So once you get here, stop, go to the next question, because this is only 1 point. Okay, and you'll see. I have to use a property of logarithms. Addition means multiplication. Because I have land on both sides of the equation, I can drop the land, and I'm left with the absolute value of 1 plus y is equal to 2 absolute value of x. Still got to get y by itself. Y cannot be an absolute value either. So I have to get rid of the absolute value. I have to get rid of that 1 that's being added to it, right? So how do I drop absolute value? I do it based upon the initial condition here. So my initial condition is f of negative 1 is equal to 1. So I'm plugging in a positive 1 in for my y. When I plug in a positive 1 in for my y, am I going to get always positive or always negative in the absolute value? Excuse me.
Always positive.
Always positive. So I get a 1 plus y. What happens when I plug in negative 1 in for x? Always positive, always negative. Always negative, so I have to multiply by negative 1. Yes. Oh, because there's land on both sides of the equation. So when you have land on both sides of the equation, the arguments are equal to each other.
So does that work if there's like logs? Is it how is the log?
Yes, as long as they're the same base.
Same base. So it depends on the base.
Yep. Yes, Amina.
What if there's not two then?
Then you have to take e. So you have to go e to the power of the right side is equal to the argument.
Wait, each. Yeah.
Is it log to the power of the base of e?
That's a great question because you're going to see that in the problem set.
Log
It's
base
like
of
every
e is
different
All right. So 1 plus y is equal to negative 2x. So y is equal to negative 2x minus 1 if x is less than 0. That's your domain restriction. Because x has to be, I plugged in a negative value in for x. And that determined what I did with the absolute value.
So it depends on what you plug in for x.
Correct. So that is my solution. So while I'm perfectly confident that you can get there, it does require a little bit of effort. And just like I'm going to ask, sometimes I have to do this weird exponent thing with logarithms, right? It's going to get weird. You try it in 4-1, you're going to see how it's strange. Okay. Questions that you guys have? All right, so your end question is question 1A.